This is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about introduction of nanomaterials and preparation of nanomaterials by chemical reduction method and applications of nanomaterials. So first, what is nanomaterial? So from the Greek, nano means dwarf or small. So nano means the particle size is very small. That's range is 10 to the power minus 9 meters. So the prefix nano means 1 billionth or 10 to the power minus 9. So therefore 1 nanometer is 1 billionth of a meter. So the particle size of nanomaterials, nanoparticles are the size between 1 to 100 nanometers. 1 to 100 nanometers. So the nanoscale materials are defined as the set of substance where at least one dimension that is less than approximately 100 nanometers. So the nanoscale materials are defined as these are the set of the substances where at least one dimension is less than approximately 100 nanometers. So the nanometers of interest are most preferable because the unique properties such as optical and magnetic and electrical and other properties emerge. So that's why the emergent properties have the potential for great impacts in electronics, medicines and other fields. So in recent years already we know that nanotechnology. So nanotechnology most important in the developing fields of science and engineering and bioscience and medical field. It plays an important role nowadays. So nanomaterials or nanoparticle sizes in between 1 nanometers to 100 nanometers. So from the Greek, nano means dwarf or small is called nanomaterials. The particle size is very small and plays an important role in this growing technology. So what is meaning of nanoscale? So nanoscale is incredibly small scale of measurement. So we cannot imagine, it is very small scale of measurement. So it describes objects, process and phenomenon so that measures less than 100 nanometers in size. So nanoscale is a incredibly small scale of measurement. So it describes objects, process and phenomenon so that measures less than 100 nanometers in size. Because nanoparticle size is 1 nanometers to 100 nanometers. So here a nanometer is 1 billionth of a meter. Nanometer is a 1 billionth of a meter. So which means that nanoscale is the incredibly small. We cannot imagine how it is small. So it is incredibly small scale measurement. So the prefix nano means 1 billionth. The prefix nano means 1 billionth or 10 to the power minus 9. So therefore 1 nanometer is 1 billionth of a meter. 1 nanometer is the 1 billionth of a meter. So it is difficult to imagine just how small that is. We cannot imagine how much it is small. So here are some examples given in this nanoscale. So for example, this ball, it is visible. So its size is 1 centimeter. We can visible with our own eyes. For example, ant, it is a size is 1 millimeter. So it is also visible. For example, human hair, it is 100 micrometers. So we can visible these dimensions also. And for example, bacteria, it is 10 micrometers. For example, here virus, it is 1 micrometers. For example, DNA, 10 nanometers. So the particle size 1 angstroms to 100 nanometers. 1 nanometers to 100 nanometers. We cannot visible. We can visible by using only microscopes or electron spectroscopes only because it is particle size is very small. So it is difficult to imagine just how it is small. So it is this nanoscale is the incredibly small scale of measurement. So it describes objects, process and phenomenon that measures less than, what is the size range? 100 nanometers in a size. So what is meaning of nanomaterials? So the materials at least one dimension. That range is size between 1 nanometers to 100 nanometers is known as nanomaterials. So what is the meaning of nanoscience? So the study of materials and their properties. The study of materials and their properties at the length scale of few nanomaterials. Few nanometers is called nanoscience. So this nanoscience mainly explains the study of materials and their properties at the length scale of few nanometers is called nanoscience. So what is the meaning of nanotechnology? So the term involved in the preparation, characterization. So these nanotechnology techniques involved in this preparation, characterization and use of properties of nanomaterials in different applications. So the techniques, these nanotechnology techniques involved in this preparation, characterization and use of the properties of nanomaterials in different applications in different applications are collectively called as nanotechnology. So how can we synthesize these materials and where we can use these materials in different applications? The study of this nanomaterials is called nanotechnology. Or otherwise you can say that nanotechnology means it is design, characterization and production and application of structures and devices and systems by controlling their shape and size. It is at nanoscale. So it is also called as nanotechnology. So simply we says the study of nanomaterials and where we can use these materials in different applications. So that study is also called as nanotechnology. So how can we synthesize these nanomaterials? So this nanomaterial synthesized by using two methods. One is top-down approach and the other one is bottom-up approach. So there are two methods of preparing nanomaterials. So one is top-down approach and the other one is bottom-up approach. So in top-down approach, so the material is reduced from bulk size to nanoscale. So the material is reduced from bulk size to nanoscale. So that means macro to micro. This is called top-down approach. So the material is reduced from bulk size to nanoscale is called top-down approach. Here it's including, for example, ball milling method and nanolithography. So in these two methods, we are preparing nanomaterials in this top-down approach. And second method is bottom-up approach. Bottom-up approach. So in this case, matter in atomic or molecular level. So matter in atomic or molecular level. Matter in atomic or molecular level gets assembled to form tiny clusters. So this particle size is very small. So matter in atomic level or molecular level get assembled to form tiny clusters. Then growing into to form nanostructures. So simply we say best example is brick to building. It's the best example of bottom-up approach. Brick to building. So here that means micro to macro. So here this matter in atomic or molecular level gets assembled to form tiny clusters which grow to reach nano size. That means micro to macro. So bottom up approach. So in this it's including chemical vapor deposition, physical vapor deposition and salt gel method and chemical reduce method. So all these are we synthesize these nanomaterials in this bottom up approach. So now let's discuss nanomaterial synthesis by chemical reduction method. So last class already we discussed nanomaterial synthesis by salt gel method. Here in this session we'll discuss about nanomaterial synthesis by chemical reduction method. So in this method we can synthesize nanomaterials of different metals. Nanomaterials of different metals can be synthesized by this chemical reduction method. nanoparticles of different metals we can synthesize in this chemical reduction method. So it is the best example of bottom up approach. Bottom up approach, that means micro to macro. That means for just now we discussed already, the matter in atomic level or molecular level assembled to form little bit clusters. These clusters, when it is grow up to form nanoparticles. So bottom up approach, micro to macro. So this chemical reduction method is the best example of bottom up approach, or it is a bottom up approach. So in this method, so the metal precursor solution, so here metal precursor solution such as a metal salt solution, which type of nanoparticles we have prepared in this. So in this case we are taking precursor is that metal salt solution. So metal precursor, this precursor means starting material. Starting material. So in this method, metal precursor solution such as metal salt solution, to which part nanoparticles we can synthesize in this method. So that salt solution, that metal salt solution taken as a precursor. Taken as precursor. So it is the starting material. So this metal salt solution is treated with suitable reducing agent. Suitable reducing agent, and also we are adding appropriate stabilizing agent also added in this. For example, here metallic salt solution taken in this beaker. So which type of nanoparticles we can synthesize? That metallic salt solution only taken as a precursor. Next we'll add suitable reducing agent. Suitable reducing agent. Then we'll add capping agent, that means stabilizing agent. Stabilizing agent. So first we are taking precursor solution, that is a metal salt solution which we can prepare the metal nanoparticles. So that metal salt solution taken as this precursor. Next we'll add reducing agent, and next we'll add an appropriate stabilizing agent. Appropriate stabilizing agents are added in this. So next, after further treatment added and drying, so the nanoparticles of metal are formed finally. So nanoparticles of metal are formed finally after drying this. So for example, in this synthesis, in this chemical reduction method, we can synthesize silver nanoparticles. Silver nanoparticles mainly synthesized in this chemical reduction method. So how can we prepare these nanoparticles by using chemical reduction method? So here we are taking precursor is the metal salt solution. Metal salt solution taken as a precursor in this first beaker. Next second one, we are adding reducing agent. Reducing agent, like for example hydrogen. Next third one is stabilizing agent used added in this metal salt solution. So after further treatment and drying, so these particles of metals are formed. These nanoparticles of metals are formed. For example, synthesis of silver nanoparticles by using this chemical reduction method. So how can we synthesize this silver nanoparticles by chemical reduction method? So in this case, first silver nitrate solution taken as a precursor, because here we are preparing silver nanoparticles. So say metal salt solution taken as a precursor. So here silver nitrate solution is taken as a metal precursor, and hydrogen hydrate used as a reducing agent. So first we are taken precursor is a silver nitrate solution, because we are preparing here silver nanoparticles. So that's why we are taking here precursor is say metal salt solution is a silver nitrate solution taken as a metal precursor, and adding reducing agent is hydrogen hydrate. Hydrogen hydrate used as a reducing agent. And next we'll add stabilizing agent, that is sodium dodecyl sulfate. Sodium dodecyl sulfate used as a stabilizing agent, or otherwise so citrate of sodium or sodium citrate also used as a stabilizing agent. So this reaction is carried out at room temperature. So how can we prepare this silver nanoparticles by using this chemical reduction method? So first we are taking metal salt solution is a silver nitrate, because we are preparing here silver nanoparticles. So silver nitrate solution taken as a metal precursor, and hydrogen hydrate used as a reducing agent. And what is the stabilizing agent used in this? Sodium dodecyl sulfate. Sodium dodecyl sulfate or citrate of sodium, or sodium citrate used as a stabilizing agent. So the reaction is carried out at room temperature. So in this case it forms the transparent colorless solution. You see here, this is a transparent colorless solution is converted to the characteristic pale yellow. This is the pale yellow. So the during reaction, this is a total reaction when we are adding this metal salt solution and stabilizing agent and reducing agent during heating at room temperature. So the transparent colorless solution converted into characteristic pale yellow and pale red color, which indicates the formation of silver. This is a pale red color. So this indicates this pale red color, which indicates the formation of silver nanoparticles. So first this transparent colorless solution converted to the pale yellow color, then convert to the pale red. So the pale red color, which indicates the formation of silver nanoparticles. Then the silver nanoparticles are purified by centrifugation. Centrifugation means removal of liquids from solid. Removal of any other impurities or volatile liquids removed from solid. So the silver nanoparticles are purified by centrifugation, and to remove excess of silver ions and the silver colloids were washed at least 3 times by using distilled water under nitrogen steam. So the dried powder of nano-sized silver can be obtained by freeze drying. So here the particle size of the silver nanoparticles can be from 15 to 48 nanometers. So in this way we can synthesize silver nanoparticles by chemical reduction method. So in this, first we are taking silver nitrate solution used as a precursor, and we are adding reducing agent is hydrogen hydrate, and also we are adding stabilizing agent is sodium dodecyl sulfate and citrate of sodium. Then the transparent colorless solution converted to pale yellow, then converted to pale red color. So that pale red color indicates the pale red color indicates the formation of silver nanoparticles. Next, the silver nanoparticles are purified by centrifugation, that means removal of liquids from solid. Then to remove excess silver ions and the silver colloids, we can wash with 3 times by using distilled water under nitrogen steam. So after that, the powdered nano-sized silver can be obtained by freeze drying. So after dried, we can get the dried nano-sized silver powder. So the particle size of silver powder can be 15 to 48 nanometers. So in this way, we can synthesize the silver nanoparticles by this chemical reduction method. And in this method also we can synthesize copper nanoparticles also. One more example of this chemical reduction method is synthesis of copper nanoparticles by using reduction method. So in this case also we are using a precursor, that means metal salt solution. So here we are using nanoparticles also can be prepared by this chemical reduction method, in which copper salt is reduced by reducing agent. That means copper sulfate, we are using metal salt solution. So it can be reduced by using reducing agents such as sodium borohydrate or hydrogen used as a reducing agent, and stabilizing agent is ascorbic acid used as a capping agent or stabilizing agent. Then it is dried. and wash it with distilled water. Finally, we can synthesize copper nanoparticles by using this chemical reduction method. So now let's discuss what are the applications of nanomaterials. So these nanomaterials, the material structures or features and the nanoscale, the particle size is between 1 nanometers to 100 nanometers. Already we know that nanomaterials particle size is 1 nanometers to 100 nanometers. So its particle size is very small, so it exhibits very unique properties and it behaves compared to the bulk counterparts. So it shows more unique properties than their bulk properties because this particle size is very small and it shows very unique properties compared to their bulk counterparts. So these distinctive characteristics it make nanomaterials applicable in various fields. So that's why it plays an important role in various fields. So some of the important notable applications of nanomaterials given here. So first one is medicine and healthcare. So this nanomaterials plays an important role in this medical field. For example, here drug delivery systems. So these nanomaterials can be designed to carry and deliver drugs with precision and improving targeted therapy and minimizing side effects. So it plays an important role in this medical field. It's including, for example, drug delivery system. So this nanomaterial, what we can synthesize, what we can design for this purpose, it improving the targeted therapy. And minimizing side effects. And next one is diagnostic imaging. So in this case, nanoparticles can enhance the contrast in medical imaging techniques like MRI, CT scans and ultrasounds. And third one is biosensors. So this nanomaterial based biosensors enable highly sensitive and specific detection of biomolecules. So it helping in early diseases diagnosis. We can easily detect cancer, for example, in early stage also. So by using this nanomaterials, so this nanomaterials or nanotechnology plays an important role in this medical field, mainly identification of tumors, cancer tumors in early stage. And if we do not any side effects, minimizing the side effects by using this nanoparticles in this medical field. So next application is electronics. So this nanomaterial plays an important role in this electronics also. So this nano electronics. So here nanomaterials contribute to the development of smaller, faster and most efficient electronic devices. When we synthesize for these electronic devices by using these nanomaterials, it increases the efficiency of electronic devices, and it is very small and rate of fastness also more, and more efficient electronic devices produced, synthesized. So next one is flexible electronics. So these nanomaterials enable the fabrication of flexible and transparent electronics. So such as flexible displays and wearable devices we can synthesize by using these nanomaterials. So next one is energy. So in this mainly we discuss solar cells and energy storage. So solar cells. So here nanomaterials enhance the efficiency of solar cells. So this nanomaterials enhance the efficiency of solar cells by improving light absorption and charge transport. So next one is energy storage. So these nanomaterials are used in batteries. And supercapacitors to enhance the energy storage capacity and charging. So when we are using these nanomaterials in the synthesis of batteries, it enhances the efficiency of batteries and storage capacity also more. So that's why most prefer these nanomaterials in energy storage devices. And it is used as a catalyst. So in catalysis process also we are using this nanomaterials used as a catalyst. So here generally catalyst used for to increase the rate of the reaction or speed up the reaction. So in this case, nanomaterials provides generally a high surface area. It provides high surface area. So it leads to improve the catalytic activity in chemical reaction. So to speed up the reaction. So this is crucible in industrial process and environmental remediation also. It is important. And next one is material science. So strengthening the material. So incorporating nanomaterial can enhance the mechanical thermal properties of materials. It enhances the mechanical and thermal properties of materials. So it leads to stronger and more durable products. So when we are using this nanomaterials, so it improves the strength of that materials. So it improves the strength means that is thermal properties, mechanical properties. So it leads to stronger and more durable products. So self-healing materials. So these nanomaterials used to develop materials that can repair themselves with damaged. So self-healing materials also we can synthesize. This is the main property of nanomaterials. So when we synthesize these materials by using these nanoparticles or nanomaterials, it improves the strength like mechanical or thermal properties of materials. So improve the strength of the material. That's why we prefer these nanomaterials. And environmental remediation purpose also we are using this nanomaterials. So in this mainly we discussed water purification and air filtration purpose we are using this nanomaterials. So here for example water purification, so in that nanomaterials like nanoparticles and nanocomposites, nanoparticles or nanocomposites, generally these are used for efficient removal of pollutants and contaminations of water. So when we are using these nanomaterials like nanoparticles or nanocomposites, which are used for efficient removal of pollutants and contaminants from water. So this water purification purpose also we are using this nanomaterials for removal of pollutants and contaminants from water. So in these filters we can use this nano filters in water purifiers also. And next air filtration. So these nanomaterials are employed in air filtration system to capture the removal of harmful particulate matter. So reduce the air pollution also. So air purification purpose also we are using this nanomaterials. And next textile industry. So nowadays most prefer this nanoparticles, nanomaterials in this textile industry. So here because this smart fabrics preparation purpose we are using. So here nanomaterials are integrated into textile to import properties like water resistance, UV protection and antimicrobial activity. So in this textile industry also we prefer this nanomaterials because preparing smart fabrics. Smart fabric preparation purpose we are using these nanomaterials because these are the integrated into textile to import the properties. So which type of properties improve this here? For example, water resistance and antimicrobial activity and UV protection. So that purpose we are using this nanomaterial for synthesis of smart fabrics. Synthesis of smart fabrics. And also used for sensors in clothing. Sensors in clothing. So nanoscale sensors embedded in fabrics can monitor physiological parameters and provide health related information. So textile industry also prefer this nanomaterials. Next we preferred in food industry. So in food industry mainly used for packaging and food safety purpose. So for example food packaging, so these nanomaterials are used for food packaging. So in this case to enhance the barrier properties, that means delays spoilage, there is no wastage, preserve it easily, and monitor food freshness purpose we are using this food packaging purpose this nanomaterials. And food safety, so nano sensors can detect contaminants and pathogenic in food. So it's ensuring the safety and quality. So food safety and food packaging purpose we are using this nanomaterials for packaging purpose and detection of food poisonous. And next Aerospace and automotive. So in aerospace industry also we prefer this nanomaterials. So for example, because the lightweight materials generally we are using in aerospace industry. So nanomaterials contribute to the development of lightweight and strong materials. Lightweight and strong materials, which improving the fuel efficiency in vehicles and aircraft. So that's why we preferred in aerospace and automotive industry because these are lightweight. So provide strong materials and coatings. So nano coatings provide protection against corrosion, wear and environmental degradation. So that purpose also we are using this nano coatings in automotive and aerospace industries or vehicles. Next one is consumer products. So here generally it's including cosmetics and electronics used as a consumer products. So this nanomaterials used in cosmetics for improved UV protection. Nowadays we preferred most these cosmetics because of UV protection and enhanced drug delivery in skincare products and better color dispersion purpose. Also we are using this nanomaterials in this cosmetics. So and next electronics. So nanomaterials contribute to the development of smaller and more efficient consumer electronics. So these nanomaterials used as a consumer products such as cosmetics and electronics we preferred in this. So it's important to note that the while nanomaterials offer numerous benefits, that means large benefits. So nowadays this nanotechnology or nanomaterials used in almost all field, like it plays important role in this medical field, electronic field, automobile, cosmetic, consumer way. So many ways we are using this nanomaterial because it's small particle size is small and plays an important role. It improves the properties and efficiency of that materials. So that's why we preferred in various industries also. So in this session we'll learn about how can you prepare nanomaterials by using chemical reduction method, and what are the applications of nanomaterials in various fields. How can we use this nanomaterials? And so I hope understood all. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.